And this is honors geo, law of sines, law of cosine. So we've done so far with our trigonometric functions. We've done sine as opposite over adjacent, cosine as opposite over hypotenuse, cosine as adjacent over hypotenuse, tangent as opposite over adjacent, SOHCAHTOA, and all of those involved right triangles. Well, now we're going to find out how to use law of sines and law of cosines to find the lengths and angles of triangles that are not right. And we use this using the premises of a right triangle. So the first concept is that of the law of sines. So for the law of sines, if we have the triangle uh, ABC, right, and opposite of those triangles, opposite of A is little a, little b, little c. The law of sines says, this is law of sines. The law of sines says that the extended proportion of the uh, sine of the angle over the opposite side of each three sides are proportional. So sine of A over sine of B over sine of C over A, B, and C. They are proportional. They are proportional. And they are used for right triangles. Now, um, there is a proof for this. If I was to actually draw an altitude straight down and call this H. Okay. I have a right triangle here. I have a right triangle here. I can say, okay, sine of A, step one, sine of A over, sine of A is equal to opposite over adjacent, which is H over the hypotenuse is B, opposite over the hypotenuse, opposite over hypotenuse, and hypotenuse is B. If I was to multiply both sides by B, I would have B sine of A equals H. I can also use the other right triangle and say sine of angle B, which is also opposite over hypotenuse. Multiply both sides by A, and I can say A sine of B equals H. Well, look what I have. I have that they are both equal to H. So if they're equal to H, they can be equal to each other using substitution. So I'm going to substitute B sine of A is equal to A sine of B. Then I can divide both sides by A and B, and if I divide that by A and B, I can divide that by A and B. The A's cancel over here, the B's cancel over here, which leaves me with sine of A over A is equal to sine of B over B. And if I was to draw another altitude and call that H, I can solve it for C and the other triangle. And since I already have one of the two ratios equal to each other, then I can use transitive property to say they're all three equal to each other. And that's how law of sines work. We'll use those in a second. The other concept is solving by using law of cosines. Law of cosines is a little bit more intricate. The proof is a little bit more intricate as well. Alright, so the law of cosines. The law of cosines says that for a triangle ABC, a squared plus b squared a squared is equal to b squared plus c squared minus 2bc cosine of angle A. B squared is equal to a squared plus c squared minus 2ac cosine of b, and c squared is equal to a squared plus b squared minus 2ab cosine of c. This is the law of cosine. Now the proof for this one is a little more intricate. So if we talk about the proof, alright, we'll still have this, but this c, let's say we break it up into two parts. We have an x over here, and then we have a c minus x over here. Condition number one, looking at this right triangle over here, I can say that cosine of A is equal to adjacent over hypotenuse, which is x over b. So then I can multiply b on both sides and say b cosine of A equals x. B cosine of A equals x. So this is my first condition. Second condition, on the other side, I can say that A squared is equal to x squared plus, oh, no, my second condition, looking at this one, I can use Pythagorean theorem and say that b squared here is equal to x squared plus h squared, using the Pythagorean theorem. Okay? So those are my two conditions that I got from here. Cosine of A, adjacent over hypotenuse, x squared plus h squared equals b squared. Okay? So we're going to use the Pythagorean theorem. And we're going to use the Pythagorean theorem to say, on the other side, looking at this A, we can say that this is hypotenuse, so A squared is equal to h squared, or c minus x squared, plus h squared. Okay. C minus x squared. We're going to expand this out using FOIL, and that gives me that a squared is equal to c squared minus 2cx plus x squared plus h squared. Well, if you look over here, I already know that b squared equals x squared plus 8 squared. So I have x squared plus 8 squared here. I have x squared plus 8 squared here. So this equals b squared. So I'm going to substitute. And I'm going to say that a squared equals c squared minus 2cx plus b squared. Isn't that nifty? And I also have up here that x is equal to b times cosine of a. So for this x over here, I can substitute b cosine of a. So I'm going to say next that a squared equals c squared minus 2 cb cosine of a plus b squared. And then I'm going to bring p squared to the front and say that a squared is equal to b squared plus c squared minus 2cb cosine of a. That's the first condition. And then I would draw an altitude from a to this side, an altitude from b to that side, and set it up the same exact way. And I would get my other two equations, setting up with the other two altitudes. So that is the proof for law of cosines. So let's try a couple of these problems. Here they want us to solve a triangle using law of sines. So let's try number one. Number one, we have ABC. We have A, we have 9, and we have C. We have 85, we have 29. Well, we could find the other angle by subtracting 180 minus 29 and 85. And I get 66. So that's good. Then I can use law of sines to find the other two. So I can say sine of 29 over A is equal to sine of 85 over 9. Okay. Multiply both sides by 9. Multiply both sides by A, and I get 9 sine of 29 equals A sine of 85. Divide both sides by sine of 85, and I get 9 sine of 29 over sine of 85 equals A, and I get that A is equal to 4.38. B is equal to 9. We already solved the two angles, so now we have to find C. Alright, I'm still going to keep the sine 85 and 9. But on this side, finding C is going to be sine 66 over C. Yeah. So this is going to be C. This is going to be 66. This goes into 66. And C equals 8.25. Okay. So that's solving that using law of sines. Pretty straightforward. So using law of cosines for number 4. Oh, thing to note. Using law of sines, you're usually given two angles and a side opposite of an angle. Or you are giving two angles with the side in between those two angles, but it's still opposite of one of those angles. Or you're given two angles, or two sides rather. As long as that other angle, that one angle is opposite of that side, you can use law of sines. Instead of law of cosines, you get three sides, or you get two sides where the angle is included in those two sides given. Then these are laws of cosines. All right, so to repeat, two angles and a side gives you law of sines, two angles and a side, or two sides and an angle where that angle is opposite of one of the sides given. Or for cosines, three sides, or two sides and the angle included in between those two sides. You use law of cosines. All right, let's try number 4. Number 4 is going to be a little bit longer because it's law of cosines. So you get triangle ABC. We have a 6, we have a 5, we have a 4. Okay, so we have to use law of cosines 3 times to find each individual angle. So for A, it's going to be, just to refresh you, A squared equals B squared plus C squared minus BC 2 BC cosine of A. It fit, y'all. Come back here. B squared is equal to A squared plus C squared minus 2AC cosine of B, and C squared equals A squared plus B squared minus 2AB cosine of C. So to find, we have all the three sides. So to find the first angle, A squared is opposite of A, so that's 4 squared. 4 squared equals, and then B squared is opposite of B, 6 squared plus C squared, which is 5 squared, minus 2 times 6 times 5 cosine of A. So this is 36, 25, 16. So I'm going to subtract that from both sides. So 16 minus 36 minus 25. I get negative 45 over here. This is 2 times 6 times 5, so that's 30 times negative 2, so that's negative 30 cosine A. Divide both sides by, 60. Divide both sides by negative 60. That gives me 45 over 60. I'm not going to simplify. Let's do this. Alright, so here, at this point I'm going to inverse cosine both sides. So it's going to be cosine inverse of 45 over 60. And that's going to give me angle A. And then angle A equals 41.41 degrees. So that's that guy. Doing it for angle B. B is 6 squared, so it's going to be 6 squared equals A, which is 4 squared plus 5 squared minus 2, 4, 5 times cosine of A. So subtract 36 minus 16 minus 25 gives me negative 5 is equal to 4 times 5 is 20 equals negative times 2 is negative 40 cosine, whoops, this is cosine of B. Divide both sides by negative 40, so I have 5 over 40. Again, I'm not going to simplify, I know it's 1/8 equals cosine of B. I'm going to inverse cosine both sides. So inverse cosine of 5 over 40 equals angle B. And I get 82.83. Now at this point, I could use log cosines again to find the other side. I could. And I would still get, the same answer. Or, since I already have two angles, I can just use triangle sum theorem and subtract those two to get my other guy. Either way gets you there. You decide which one you like best. 180 and I get 55.77 degrees. So those are my three angles. So I have this guy, this guy, and this guy. Again, using law of cosines. And the reason why I use law of cosines is because I have three sides, or two sides where the angle is included, law of cosines. And again, two angles on the side opposite of one of those angles, or two angles on the side included in one of those two angles, or two sides and an opposite angle will give me law of sines. That is this section, guys. Hope you have a great rest of your day.